Welcome to Integration Methods Podcast number 4. What we want to look at now are integrals that are not yet able to integrate. These are problems that we cannot use a method of substitution. Some of these are like the integral of ln x e to the 2x, x sine x, cosine squared x. All of these we're not able to do. And so what we want to do is develop another method for doing them. This method is going to be called integration by parts, and before we actually do that, what I want to look at is just one thing, and that is if I have the antiderivative, or the integral of x squared, we know that's equal to x cubed over 3 plus c. If I take the derivative of both sides, well, what I'm going to do is take the derivative of the right side. The derivative of x cubed over 3 is certainly going to get us back to x squared. The derivative of c is 0. And what you should realize and already know is that when I take the antiderivative and find the derivative, I get back to what I started with. So the idea is that if I take the derivative of the of the integral of f of x, I get back to just f of x. Okay, integration by parts, what is it? Well, what we're going to do is we're actually going to use the product rules to derive it. And you should know that the derivative of a product of two functions is, in this case, u dv dx plus v du dx. We've seen that a lot. What I'm actually going to do in this case now is I'm going to multiply both sides by dx, and so that dx cancels out. And so while it looks a little different, it still means the same thing. This is called differential notation. But it still means the derivative of a product of u and v is u dv plus v du. Well, how does that help me? What I'm actually going to do is I'm going to solve for this u dv, which means I have to subtract v du from both sides. I'm then going to look at that problem, and I'm then going to integrate both sides. So I have the integral of u dv, the integral of the derivative of uv minus integral of v du, and one more step, and that is, as we now know that the integral of the derivative of uv gives me just u times v. So what we have is this formula that's going to look like this. And this will also be on the next page as well. So integration by parts looks like the integral of u dv equals uv minus integral of v du. And it'll take a while to get used to that. You probably want to write it down while you're working with it. The idea is this, is what I'm going to do is I'm going to take an integral and I'm going to try and break it up into parts of u involving u and v and du and dv, rewrite it so it looks like this, and hopefully I can integrate that new integral over there where I couldn't do it to begin with. So let's give that a try. Using integration by parts, let's find the integral of ln x dx. I have to set up a u and I have to set up a dv. From that u, I'm then going to take the derivative of u, and then from that dv, I'm actually going to find the antiderivative and get v. So I can substitute back in here. Well, I only have two choices. I can let u be ln x or dx. I could let dv be equal to ln x or dx. But I can't take the antiderivative of ln x. That's what I'm trying to do to begin with. So I'm going to let u be equal to ln x. I know that the derivative of that is 1 over x. Now in the formula, we're only using du's and dv's. So like we did with substitution, I'm going to multiply both sides by dx. So what I end up with is that du is equal to 1 over x dx. Well, since I've already used ln x, that means all I have left for dv is going to be dx. I'm trying to substitute in, so I use that whole thing. Well, if dv is equal to dx, then v, the antiderivative, is going to be equal to x. And while we've always added a plus c, for this particular method, I'm going to leave that plus c out of it, and we'll learn why we can do that later on. Now that I have done all of this, I can substitute all of this back into my formula for integral of u dv. So the integral of ln x dx now can be written as u times v. U times v is x times ln x minus the integral of v, here's v, times du. So I'm going to have x times 1 over x dx. Now let's go down one more step. So it's x ln x. I can now simplify that integral, and I'm going to get the integral of just 1 dx. That I can integrate. So I have x times ln x minus x, and now I will add back that c. That should be our answer. If it is our answer, we should be able to take the derivative and get back to what we started with. So let's actually do that. I'll have it on the next one. So if the integral of ln x dx is this x ln x minus x plus c, if I take the derivative of this, I should get back to what I started with. So let's do that. Well, to take the derivative of x ln x, I have to use the product rule. So it's going to be the first times the derivative of the second, or x times the derivative of ln x, which is 1 over x, plus ln x times the derivative of x, which is 1, minus the derivative of x, which is 1, and the derivative of c is going to be 0. So I end up with 1 plus ln x minus 1, and I do get ln x. I do get back to what I started with. And that's how it works. Let's try another one to help cement the idea. Integral of x sine x. Again, my goal here is to do a substitution, a u, and a dv. Well, I have to be able to take the derivative of u, which isn't a problem, but I also have to be able to take the antiderivative of dv, which in this case is not a problem either. So what I'm going to do is do what we talked about before, and that is I'm going to take just x. And the reason I'm using x as opposed to sine x is when I take the derivative of it, it becomes more simple. In other words, I just have just 1. Solve for du, and so du is equal to 1 times dx, or just dx. dv then is what's left. So dv is equal to the sine of x dx. Well, the derivative of what is the sine of x dx? Well, the derivative of negative cosine of x. Again, I'm going to leave out that plus c. Let's put it all together. So the integral of x sine of x dx can be rewritten as u times v. Well, here's u, here's v, so I'm going to have x times minus the cosine of x minus integral of v du, which is minus cosine x dx. So let's simplify that. So I have negative x cosine x plus the integral of cosine x dx. That I can integrate. So we have negative x cosine x. The antiderivative of cosine x is the sine of x plus c. And again, the idea is if you take the derivative of this, I have to get back to what we started with. Let's go back, just to give you a chance to copy that one down. So what I have next is what we've been talking about, is when you're setting up integration by parts, you have to choose this u and this dv. So when you choose u, really doesn't make a huge difference because we can pretty much take the derivative of anything. You have to be able to find du. dv, that's the trickier one. You always have to be able to find v, which is the antiderivative of dv. And lastly, once you've set it up, you have to be able to, hopefully, integrate that v du. And if you can, then you can do the problem. So let's try one more. Let's do the integral of x times e to the 2x. Again, I can take the derivative or the antiderivative of both of those, but I want it to get simpler. So I'm going to let u be equal to x, and I'm going to let dv be equal to e to the 2x dx. So when I take du dx, that is equal to 1, or I just go right to du is equal to dx. When I take the antiderivative of e to the 2x, we have to remember about the chain rule, about that 2. And so that's equal to e to the 2x over 2. Let's put it all together. So the integral of x e to the 2x dx can be rewritten as u times v. And u times v is going to be x times e to the 2x over 2 minus v times du, and that's just going to be e to the 2x over 2 times dx. So let's rewrite this as 1/2 x times e to the 2x minus, let's bring that 1/2 out front, e to the 2x dx. That I can integrate. And so we end up with 1/2 x times e to the 2x minus 1/2 times e to the 2x again over 2 plus c. And if we take the derivative of that, we will get back to what we started with. Take care.